Alright, I'm going to do these. You got it now? Oh. Find some mistakes?
Yeah, we found a major mistake.
Good. Find a major mistake. Good.
I just saw him thinking of that.
Okay.
He's taking it? I think so.
Gabriella? Yeah. You guys done?
Yeah. Is he driving? No. I don't even know. His license was suspended, so.
Do you need a ride somewhere, bro?
Huh?
Do you need a ride somewhere, bro? Do you need a ride somewhere? Do you ride home?
Sunday at midnight. Yeah.
Alright, I need you to
I
get
can
your
give them.
notes out. We're going to get started on a problem, and then I'm going to do these when they
But
get their
I used to live like 2
paperwork
minutes away
in
from
finally. So I want you to look on the back of page 6. This is the very last topic. So again, we're looking at a test probably the end of next week. Depending on how those long block days go, it might be the beginning of the next week, but it's soon. It's relatively soon. We're going to be having a test. When is homework due? Wednesday. So let's be working on that. This is your last weekend to kind of get some of that stuff sorted out. There is Sunday open gym this week, 2 to 4, as we've had in the past in this room. And yours truly will be there. So if you can come in, that would be great. It's up to you. But we're going to do this last thing right now. So you have been given a formula. I'm going to do that problem in a second. That's why it's still up there. You are not responsible for memorizing this. What you are responsible for is knowing what each of these variables represents. Okay? Somebody said velocity, and you're right. One of them is velocity, time. One of them is time. Very good. You guys are ahead of the game. Let me do this problem real quick so I can get it out of here. Well, we're in our notes. I don't care if you write this problem down or not, but we're going to our notes now.
That's a impulse.
We draw a number line, and right in the middle of the number line, we put a 3. That's the opposite of this number, right? And then from that 3, we're going to count out here, and we're going to count back here. How many units? 4. So 3 plus 4, I hope you put a 7 out here. 3 minus 4, I hope you put a -1 back here.
Yep.
And we're all done except the shading. So this problem is a greater than, and greater thans get shaded out, away. So out here. So our answer would be x is less than -1 or x is greater than 7. X is less than -1 or x is greater than 7.
No, I got that one.
Okay? That's that one. Now, this one. Hopefully you factored it.
How we?
-4 minus 2. That's how we end up with 6 in the middle and 8 on the end. Then you go right back and draw your number line again. And the 2 dots on the number line this time are at 4 and 2, and they are closed. And since it is a less than, it is shaded inside. And your answer can most easily be written this way. Now there are other ways to write the answer. All right, now listen carefully. This wasn't intended to lower your grade. This was intended to be gimme points. But for some of you, it didn't work out that way. So you have one more chance to redeem yourself. If your group cares, this is a 6-point exercise, okay? This was 6 points. If you turned it in first, on the first time around without notes, and you got everything right, you're gonna get 6 out of 6. If you turned it in after the notes, you're gonna get 5 out of 6. If you turned it in and got it right. If you turned it in after the notes and still got it wrong, things are not looking very good for you. But it's only 6 points. If you want to come in and do this same kind of problem again with your group, that's the kicker. You gotta come with your group. You can do that before school on Monday. It doesn't take very long. You could get here at 7:30, 7:35 with your group, you can get your points back if you care about that. Okay, otherwise you'll just have to do this in a Okay, got it? Everybody got it? Now,
I'm not gonna come.
wait. If you have 0 period, I will accommodate you. Because on Monday morning, I will be in the weight room. I will have quizzes with me, and you will come in early before 0 period.
Well, we're in this group.
Well, you gotta come too.
Like what? You're not in 0 period, right?
Well, you can stay after school today.
Are you?
Yeah, 0.
Oh, we can stay after school
You
today?
can stay after school today.
Alright, you just want to do that?
Okay.
Okay.
Alright, here we go. Here we go.
No, I'm playing not 0.
In this formula, T stands for time.
Oh, what's the function?
That can vary. It's usually seconds. Quite honestly, in these problems, it's usually in seconds, but it can be whatever unit. V sub naught, that's a little 0 there. So it's a V with a subscript of 0. That stands for the initial velocity. So these problems are called projectile motion problems.
Yep.
And those of you in physics, you know about projectile motion. Projectile motion is what happens when you throw a ball into the air. So you football players, when that guy goes back and throws that football, that's projectile motion. When the kicker kicks the football, that's projectile motion. Okay, it's a motion or an object being projected into motion. So when you throw that ball, the initial velocity is however fast you can throw it. So aren't there baseball players that do it like 90 miles an hour or something?
Yeah.
If you stood on top of the building and dropped the ball, so it's in your hand and you just open your hand, then the velocity is 0 because you didn't throw it, you just dropped it. So sometimes the initial velocity can be 0. S sub naught, and again, that's a little 0 there, so it's S with a subscript 0. That is the initial height.
Oh, that bothers me.
So if I am the football player throwing the ball, then the initial height would be, I don't know, I'm 5'6", so what would that be? 4 feet, 10 inches or something would be the initial height. If you stood on top of the roof, then it would be 20 or however tall the roof was. If you're kicking the ball from the ground, then the initial height would be 0. So these can be 0 depending on the situation. This, while it looks like 2 variables, is really just one. This is the height at time t. So this is the height at the beginning of the problem. This is the height after 1 second or after 2 seconds. This is the height at a particular time. And every equation where the height, the distance is measured in feet, is going to have a negative 16. If it's measured in meters, it'll be a different number. But for height in feet, we use negative 16. That's the gravity constant. Okay? All right. So that's the formula we're going to use. So let's look at the first problem in our notes. This is on page 7, down at the bottom, number 4. A rock is thrown from ground level with an initial velocity of 32 feet per second. This formula will be given to you. Now you have to modify it to suit this problem. So S of t will be negative 16t squared plus what? What am I going to put in for v sub naught? Read the question. Isn't that going to be 32?
Yeah.
What does that stand for? Initial velocity. It says the initial velocity is 32. So I'm going to put a 32 there. Now notice I still have to have the t. That goes in just for the v. Plus, what is the initial height in this problem? 0. Why is the initial height 0? We're on the ground. When you're on the ground, your height is 0. So I'm not even going to put anything. I'm just going to leave that off. Okay? Now, if this bothers you, you can think of that as Y or H. Whatever you want to do. You can think of it as a single letter. Sometimes the function notation bothers us. Remember last year when you did f of x? Okay, and you called it y? Well, this is the same as f of x, only the letters are s of t. So you can think of it as y. So now I have an equation that looks like this. And I'm going to answer 3 questions about it. All right, so the first question is, when will it hit the ground? So think about what's happened. Somebody has a rock, and they have thrown it up into the air. I'm still on the first page, number 7, down at the bottom. A says, when will it hit the ground? I've thrown the rock up into the air. What is going to happen? It's going to come back down, right? So the question is, when is it going to hit the ground? So I want you to look at the equation that you wrote. This, remember, is the height variable, and this is the time variable. Every one of the questions is going to give you the height or give you the time. You have to have one of them. So when I read this problem, does this problem tell me, this question, does it tell me anything about the height?
Yes, it does.
Or does it tell me anything about the time?
It does about the height.
It tells me about the height, because what does it say about the height?
When it hits the ground, it's going to be 0.
It hits the ground. So this is going to be 0. This is the equation you are going to solve. Boys and girls, it says when does it hit the ground. T is your variable. T is what you're looking for. That's what I don't know. I don't know T. But I know the ball's on the ground, right? It's on the ground, which means the height is 0. Can I factor that?
Yeah.
What can I take out?
16 in T.
A negative 16t?
Yeah.
And if I pull out the negative 16 and a t, what am I going to be left with?
T plus.
Oh, watch it.
T
T
plus minus 2.
minus 2. Why is that a minus?
Because minus is
Because I
positive.
pulled out the negative, and that would multiply back to give me a positive, right? So now I'm going to set both of these equal to 0, because I need to figure out what t is. That's my answer. My answer is, when does it hit the ground? So I get 2 answers. I get 0 and I get 2.
Because it started at 0.
Because it started at 0. Remember, people? Where did the ball start?
0.
On the ground. So we said, when is the ball on the ground? Well, it's on the ground at 0 at the beginning.
You're always going to get that answer.
But then it's also on the ground at 2. So when did it hit the ground? After 2 seconds. That's when it hit the ground. After 2 seconds.
Why is S initial height in pre-calc, but in physics it's impulse?
I don't know. I have no idea. Okay, wait, I don't want to erase my equation, because I need that to do the next problem. All of the problems, all the questions for this problem are going to use this equation. This is our equation that we're going to use. So let's look at B. How high will the ball be after 1/2 seconds? Now remember, this is the equation you are working with.
Plugging in half for T.
Okay? Every question will either give you a height or give you a time.
Are we on the one above?
We're on problem B. Turn the page. On the back of page 7, problem B. How high will it be after 1/2 second?
You're going to plug in half a second in T.
I'm 1/2 second is the time, right? So all we're going to do is plug in a half. And that's going to give us our answer.
They're just solving really.
So what is 1/2 times 1/2? 1/4. And what is -16 times 1/4? -4. Now for those of you that are a little bit lost by that, remember 16 over 1 times 1 over 4. That would give you -16 over 4, which is -4. What's 32 times 1/2? 16. So the answer to the question is 12 feet. How high is it after 1/2 second? We just plugged in 1/2 and came out with 12. All right, one more question. Using the same equation, kids, you're going to use that same equation in this particular problem. When we go to the next problem, oh, wait a minute, that's why you were so confused. I turned the wrong page. Oh, I'm sorry.
Wait, what?
That is my fault. I turned the page and I'm doing a whole different problem.
I'm so confused.
Okay. All right, so let's go back. Let's go back to number 3 on the back of page 6. Go to the back of page 6. So the ball is thrown off the top of the building. Okay, I didn't do that problem. Okay, I'm on number 4. I went to the wrong problem. So I'm on number 4. We're good. We're answering the questions on number 4. Yes. Okay, so this is 4B, and now we're going to do 4C. And then we'll go back and do number 3.
Wait, we're doing 4B right now?
No, we're doing 4C. This was 4B, right here. So I went to the bottom of page 7. Okay, turn to page 7 in your notes. Everybody on page 7? I have done problem 4 down at the bottom. I know not yet. I did 4A first. I have now erased it, but it was over there. Then I just did 4B right here.
I've been doing it all on 3.
That's okay, just mark it, make it 4. It doesn't matter, just change it. When will it be 20 feet high? Now I'm on C. When will it be 20 feet high? Now remember, 2 variables. One of them, you know, they have to give you one of them. So in this case, they said 20 feet. So is that going in for the height, or is that going in for the time? The height. So 20 equals -16t squared plus 32t. Now we're going to solve it. How do we solve this equation? I would subtract the 20. That's exactly right, Shiloh. I would subtract the 20. When you have a quadratic equation, you want to get it equal to 0.
So now we have 3 different ways to solve it.
So you can try to factor it. You can try to complete the square. You could use the quadratic formula. But before I did any of that, I would notice what Q noticed. Everything here can be divided by 4. So I would divide, and you know, actually, let's divide by -4. Do you have to? No. But that'll make this positive, and I like it better when that's positive. And it's all about mean, right? I'll make that positive. So 0 equals 4t squared minus 8t plus 5. Now, looking at those numbers, I don't think it factors. So that's why we learned what we learned. So we can either use the quadratic formula or complete the square. I would not complete the square, and I'll tell you why. We can't have a 4 here.
Think I
So
divided
I would have to divide everything by 4, and that's gonna make a fraction out here. I'd rather not do that. If that were not a 5, if that was something divisible by 4, it'd be fine, but it is a 5. So I think I'm just gonna use my quadratic formula. So now I don't need this anymore, so I can erase it. My quadratic formula says
double formula problem.
negative b plus or minus the square root of b squared minus 4ac all over 2a. Everybody okay with the numbers? Remember, this is my equation. So a is 4, b is negative 8, and c is 5. You okay with that? All right, so what does this equal? 64 minus 80?
Yeah.
Wait.
Yeah, it is. Yeah, that's what I got.
Okay, I know, but that's bad.
Yeah, negative 16, so we have to pull out an I, correct?
Okay, wait, but stop. This question was, when will the ball be 20 feet off the ground? And you're telling me it's going to be an imaginary answer?
So that means no solution.
What does that mean in terms of the problem? It never gets that high.
Yeah.
It never
it's not
gets that
possible.
high. When will the ball be 20 feet off the ground?
Never.
It doesn't get that high. It doesn't get that high. So the answer to the question is, yeah, never. It doesn't get that high. It doesn't get there. Never.
It will not
Just
get
say
that
never.
high, baby.
Now, obviously, if that had not been a negative, then we would get answers out of this, right? But because that came out negative, it would be like, here's the ball, okay? And up here's 20. The ball goes up, but it doesn't go up high enough to get to where we wanted it to get. All right? Okay, let's go back to number 3. Now we're going to build a new equation. We're going to start with the same formula, which you do not have to memorize, but you do have to be able to build the equation for problem number 3. So here we go. A ball is thrown off the top of a building 12 feet tall with an initial velocity of 18 feet per second. So, I'm going to go ahead and make this y. And what goes in for v? 18. And what goes in for s sub naught? 12. So this is your formula this time. So when you do problem A, and I'll do the right A, the one right under number 3. When I do problem A, that's the equation I'm using. When I do B and C, that's the equation I'm going to use. So here we go. When will it hit the ground? So keep in mind, you either have to put a number in here, or I got the hiccups, or you have to put a number in here. When will it hit the ground?
Y equals 0, solve for 2.
Means the height is 0. What? The ball is on the ground. Remember, this is the height variable, and this is the time variable. And in order to solve the equation, you have to plug one of them in. You have to plug one of them in.
It's 0 feet.
If the ball is on the ground,
Like not moving or doing anything.
how high above the ground is a ball that's on the ground?
Miss Ford, it might make sense
We
if you
already
put...
did that, Shiloh. That's 12, that's the initial height, that goes here. Now we are answering question A. The ball has, here's the building. You threw the ball up, but at some point it hits the ground. And when it hits the ground, its height is 0. All right, so what do I want to do to start solving this? I'm going to divide by -2. You don't have to, but it helps me to have that be positive. So that'll be 8t squared minus 9t minus 6. What? 4 doesn't go into 18. You can do 4, but then you'd have a fraction. All right, now what?
Are you gonna quadratic formula that too?
I guess I'm going to use the quadratic formula. That doesn't look like it's going to factor.
And complete square would give you fractions.
Completing the square would be a hideous mess because of all the fractions.
9.
Alright, so I think I got it right. Did I get that right? Negative b plus or minus the square root of b squared minus 4 times 8 times -6.
24 times 8. Yeah, what's 24 times 8? Or 32 times 6.
I need to figure that out.
I'll do it right now.
81 plus what?
192, I think.
192 is right.
Yep.
And then I'm adding an 81.
Yeah.
273.
Yep.
All right, let's get a calculator out because I need a decimal.
273, 16.5.
Well, let's do this. Whoever's talking back there, let's do 9 plus the square root of 273. Hit equals, and then divided by 16. So make sure you hit equals. 9
divided by
plus.
16.
Yep. So did you do 9 plus the square root? And then equals, and then divided by 16.
1.59.
Okay. And then let's do the other one. Let's do 9 minus. Remember, because it was plus or minus.
Negative 0.47.
Okay. Now, oh, I erased my picture, but remember I had the building, and here's the ball coming up and hitting the ground. How many times, if I go to the top of the building and throw a ball up, how many times does it hit the ground? Just once, right? Doesn't it just hit the ground right here?
Well, yeah, you can draw the same thing with the graph
How
go
about
to the
it
building.
bounces?
Okay.
Depending on the type of ball.
Pretend it's a rock and it's not bouncing.
Because if you were to draw like that graph from earlier,
But
just go to the building.
if
0.
If we do it from a purely mathematical standpoint, isn't there another 0 back here?
Yeah.
But you never reached it.
But that one is no good because that would reflect negative time. That's like before I threw the ball,
It's like you found the rock.
so that doesn't count. So our only answer is 1.59 seconds. This is another example of an extraneous root. You cannot have negative time
Or negative.
or negative height.
Well, you can.
You can have negative velocity.
Can't.
Oh shoot, is this the equation?
Yeah.
Oh darn it. Alright, so tell me what the equation is and we'll do one more. Y
Final
equals
height
negative
is equal to
16t
negative
squared.
squared plus t or time, I guess. Or 32 would be the one. 32 is not given.
Sorry to that.
Plus 18t plus.
That is not given.
Alright, one more, gotta get through this problem. When will it be 15 feet above the ground? So here we go. When will it be 15 feet above the ground? So we're gonna put the 15 either here or here. So it says 15 feet.
Why?
So that goes in for y. So in the last problem, we put 0 in for y because our height, or we were on the ground, right? Now we're not on the ground, now we're up here somewhere. We're 15 feet off the ground.
Fine.
How do we solve this? Very good. Subtract the 15. Very, very good. Shooty tooty. It's a good thing we have our calculators out because this is going to be a mess.
No kidding.
Negative b plus or minus the square root of, anybody happen to know what 18 squared is? 324.
You guys got that math.
Minus 4 times negative 16 times negative 3.
192.
That's all 192.
Negative 192.
It's going to be negative. So what? So I have negative 18 plus or minus the square root of, what's 324?
132.
132 over negative 32. Now that's two answers, isn't it? So we're going to get those two answers. So we're going to use negative 18 plus the square root of 132. Wait, we got to finish it.
Good afternoon, Cathedral. As we
Stop
end
it.
this day and our week, and ask you to pause and join me in prayer. I have great news for you to share before we leave. You know that Mary, the mother of Jesus, is a patroness of Cathedral High School. That's the truth, and that is great news. So join me in prayer, please. In the name of the Father, Son, Holy Spirit, amen. Hail Mary, full of grace, the Lord is with thee. Blessed art thou among women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death. Amen. In the name of the Father, the Son, the Holy Spirit, amen. Go Irish, have a safe weekend, tell your parents you love them, and give Mr. Kabuski a big hug or a high five on the way out. He is headed up north, but he'll always be in our hearts. Thank you, Mr. Kabuski. God love you.
Okay, wait, we're going to get answers here because I got to show you something. So negative 18 plus the square root of 132 equals, divided by negative 32, I get 0.203. All right, now just hang on. Negative 18 minus the square root of 132, divided by negative 32, I got 0.922. Now, why did I get two answers? I erased my picture, but remember, here's the building. The ball went up in the air and came back down to the ground.
Because it hits that point both
It
times.
hits that point on the way up, and it hits that point on the way down. That's why there are two answers.
Can we hurry up and do those problems?
Yes, anybody wants to redo them right now, you can. I'll do second.
You guys want to redo them or
Anybody
no?
wants to redo them, this will be the first time to get Or you can come in.
Monday. Here, Maddie. Thank you.
Early and Monday aren't in the same vocabulary. I'm coming at 10 on Monday.
Yeah, me too. Just text the box that you need to or finishing up
All right, who's staying? You guys staying?
We're staying.
You're staying? You're staying?
We're staying.
Okay, I have the right one. She paid for you, Harrison.
Manchester University and people.
Oh, maybe those are your quarters. Are those your quarters?
Yes.
Oh, give these quarters back to Addie. I didn't see them. I came in and sat down.
Yeah, I
Give those to her. Hannah. Goodbye, honey. I was doing one more. So, you're leaving your salsa. Take your salsa and run. You're right, Sam. You're going. All right,
break.
Get out another sheet of paper. Get another sheet of paper. All right, here we go. Here's your first problem. And here's your second problem.
They're actually not that good. At all.
Please make sure you factor correctly on the factoring problem. Sit down. Sit down. It's group effort.